Hello. In our last video, we learned how to write a recursive method, how to write a method that calls itself, or if you're working in a non-object oriented language, you would say you're writing a function that calls itself maybe, or a procedure. And we learned that there were 4 steps, and then we applied these 4 steps to finding factorials, but these 4 steps apply in all recursive methods. So first, we write if, because we have to have at least 2 cases, a recursive case where the method actually calls itself, and a base case where the method does not call itself so that the recursion stops. So we know we can always write if. And then we handle the simplest case, the base case, the case where there's no recursive call, no looping. Our simplest input, our simplest case. Having done that, we write a recursive call in the other case, and that recursive call should be past simpler input, or the problem should somehow be made one step simpler before that recursive call. And then a suggestion is that if the recursive call returns a value, we can store that value in some variable. And then finally, we want to assume that that recursive call works and ask ourselves, what does it do? And most importantly, once we understand what the recursive call achieves, how does that help? How does solving the simpler problem help us solve the entire problem? So let's take another look at our, not that button, this one. Let's take another look at our factorial method that we wrote, and I'm assuming that we remember how to compute factorials too, right? N times n minus 1 times n minus 2. So we write if, we test our simplest input. The simplest factorial we can find is factorial of 0, and we know that the factorial of 0 is 1. And otherwise, if n is not 0, well, that must be our recursive case. So we're going to make our recursive call. That's step 3, make the recursive call, right? Write the recursive call. Make the recursive call on, let's see, a simpler input. A simpler input than n would probably be n minus 1. And in this particular problem, that is actually the correct simpler input. And the suggestion was to store that result, since it gives me back an integer, store it in a variable, and then stop and reflect. And I reflect by assuming that the recursive call works and asking myself, what does it do? How does it help me? So if I assume that I can find n minus 1 factorial, that's n minus 1 times n minus 2 times n minus 3, n minus 1 times n minus 2. I don't think I'll write that out. When I multiply all those together, well, that's really close to n factorial, because n factorial is n times n minus 1 times n minus 2 times n minus 3. So this is the entire result, the entire factorial of n is the factorial of n minus 1 times n. And you can go back to the last video if you have any doubts about where that's coming from. In this video, I would like to explore how this actually works, what the computer actually does when it computes this scary thing here. And let's see. I said it's nice to store this temporary result in a variable, and it is. Lets me think about the problem. But sometimes I might realize then that I don't need that variable, so instead of writing results, we could simply write fact of n minus 1. And then since I have only one statement, I can remove the braces, and now we can see here's maybe a more mathematical looking version of factorial where I'm not using that result variable as temporary storage. And I want to understand, what does Java do when it's faced with this? So let's take a look at Java. Here's Java, and I like to draw Java as a blob here with feet. Of course, the feet are important just in case this Java wants to, go for a jog, keep in shape. And suppose now we ask Java to perform, find for me the factorial of 3. Find the factorial of 3. In fact, maybe we will print. So this is Java's ugly way of telling it, the ugly way we tell Java to print. Maybe print out the value of factorial of 3. And 3 factorial should be 3 times 2 times 1, which is 6. So this should print 6. Let's see what Java actually does. So the first thing Java does is Java, when we say fact of 3, it starts thinking, okay, you're calling fact. And you've called fact with an n value of 3. Right? N is 3. And in fact, since Java is thinking this, we'll draw some thought bubble-ish things. So here's Java thinking about performing fact of 3. So what does it do? It says, is n 0? Nope, n is 3, 3 is not 0. So I don't go here, I go here. And Java's asked to find this computation here. Well, let's focus on the left side first. To find fact of n minus 1, I need to find n minus 1. n minus 1, well, n is 3. 3 minus 1 is 2. So this is 2. So we're asking Java to find fact of 2. So what happens? Java starts thinking, fact of 2, let's make another bubble for that. We call fact of 2. A new bubble appears. Officially, these are called stack frames, and I'm showing you what's on the stack. But something else that Java notes as it performs this calculation, see if I can go back in time so I can condense this since I need to make more room. When I ask Java to find a fact of 3, that's over here, we'll call this line A, and we'll call this line B, the two calls to fact in my program, the one out here and the one inside my factorial implementation. So here, Java makes a note that when it's done finding fact of 3, it goes back to A. This is where it's going to continue at the end of the calculation. When in finding 3 factorial, when we realize we have to find 2 factorial, Java makes a note that when it's done finding 2 factorial, it's going to go back to B, the line, B, which is the line where it was asked to find 2 factorial. Alright, so let's proceed from there. I'm just drawing my little bubbles here. Here we go. Okay, so we've now started trying to find factorial of 2. So here we go. N is 2. 2 is not 0. So now we find factorial of 2 minus 1, which is factorial of 1. So a new bubble appears. New deformed bubble. I'm going to stop writing fact each time. In this, n is 1. And when we're done finding the answer, we're going to go back to line B, which is where the method was called. Back to line B. Alright, continuing. To find factorial of 1, let's see, n is 1, 1 is not 0, so we're asked to find fact of 1 minus 1, which is 0. So, let's see if I can squeeze that in, maybe like this. N is 0, and when I say 1 minus 1 is 0, I call fact of 0, I'm coming back to line B, back to B. And, I lost some of my bubbles, but that's okay, you get the idea. So this is Java's stack. In fact, that's an important idea. Let's actually write that out. This is, let's draw that like this. This is the stack. It's everything that Java is remembering as it handles all these method calls. And every time a new method is called, or in this case the same method is called, since we keep calling the same factorial method over and over again, every time the method is called, a new stack frame, or activation record as they're sometimes called, but I'll think of them as thought bubbles in these videos. A new thought bubble appears, and that thought bubble contains all the values of variables that Java needs to keep track of as it handles that method, but also where to go back to, where to continue the computation when it finds the answer, when it completes that method call. So we notice the original method call, when it's done, we come back to line A to print out the answer, but in all the other method calls, we go back to line B because we finished the recursive call, but now we need to multiply and return a result. So this is everything that Java needs to remember. In fact, if we were to walk away from the computer and come back in an hour and take a look at this screen, that's enough for us to continue and carry out the rest of the calculation. So let's do that. N is 0. Factorial of 0. Well, now n is 0, so I know the answer is 1. So the value of this thing is 1, and that 1 is going to come back to line B. So let's do that. The answer is 1, and that 1 comes back to the previous call in line B. Here's line B. So this is 1. Back in this world where n is 1. So we're back in the world where n is 1, but we know that the answer to this recursive call is 1. So we know that that answer is 1. And now we're supposed to multiply by n. Well, n is 1. So 1 times 1 is 1, and we'll return 1. So back from this recursive call, we're going to go back to line B with the answer 1. Go back to line B. So this recursive call ended, and anytime a call ends, the bubble goes away. And we're going to go back to line B with the value 1. Something I should have pointed out, notice even though it looks in our program like there's one n, every recursive call, every time we call this, gets its own n. which is independent of all the other ends. These ends are not connected in any way. They just all have the same name because they're all the result of calling the same method, but each call results in its own thought bubble with its own end. So we go back to here where n was 2 in this world, and 1 is returned, so 1 is the value of this expression here, fact n minus 1. 1 times n, but n is 2, so 1 times 2, that gets me 2. So, and that 2 is going to go back to B. So we're going to send a 2 back to line B. So let's do that. All of this goes away, and a 2 will come back to the previous method call at line B. So 2, here's 2, coming back to line B over here. Now, fact of, that means this answer here was 2. And we've been asked to find 2 times n. N is 3 in this world, so 2 times 3 is 6. So the answer to all of this is 6. And that 6 is going to come back to line, let's see, back to line A. So we go back to line A. Factorial 3 here must have been 6, and 6 is what gets printed. We print 6, and now we see a little bit of what's going on inside of Java that allows this recursion mechanism to work, how recursion works. And we see that a big part of that is that Java relies on this stack to keep track of all of those recursive calls and what their individual variable values are and where to come back to after each recursive call. I will see you in the next video.